Hi, welcome ladies and gentlemen. My name is Oscar Alston and today I will be analysing the literature around transcranial direct current stimulation and how this procedure is currently being looked at to combat major depressive disorder. TDCS is a novel method of brain stimulation where a low voltage direct current is applied directly to the scalp to excite or inhibit neuronal activity, therefore being able to increase or decrease specific activity in different areas of the brain with the aim to reduce the negative effects of some disorders, such as depression. Major depressive disorder is known worldwide, and it's likely that each of you have encountered this diagnosis, whether it be personal or a friend or family who suffers depression. This disorder is characterized as causing persistent low moods and sadness, finding it difficult to find joy in activities that are usually enjoyable to the person, and general levels of low energy or lethargy. This can make it difficult for someone who is diagnosed to maintain a healthy lifestyle. Physiologically, major depressive disorder is caused by an imbalance of neurotransmitters resulting in chemical imbalances in the hormones such as serotonin, norepinephrine, and dopamine. The autonomic branch of the peripheral nervous system oversees keeping the body in homeostasis through the endocrine system. A careful balance of hormones is required to keep the body in its optimal zone of operation. Strakowski and Nelson have described that a root cause for this imbalance lies in the dorsolateral prefrontal cortex and the ventral prefrontal cortex. These areas of the brain have been used for cognitive control and emotional control, respectively. The two areas of the prefrontal cortex are reciprocally connected, so a decrease in dorsolateral prefrontal activation can allow excessive activity in the ventral prefrontal cortex. It has been observed that people who suffer from depression usually have more activity in the ventral prefrontal cortex and less in the dorsolateral prefrontal cortex. Effective treatment of depression has also shown that an activity balance returns to these two areas of the brain. TDCS is a novel method aimed at exciting or inhibiting neurons in the brain. Compared to other methods, it is less invasive and relatively cheap to administer. The process involves attaching electrodes to the scalp using either a rubber electrode and a conductive gel, or enclosing the electrodes in a perforated sponge that is doused in saline solution. Direct current is then passed through the electrodes. Anodal stimulation, which is a positive charge, is used to increase excitation at the membrane, and cathodal, or a negative charge, is used to decrease excitation. In humans, it is common to use 2 milliamps of current over a duration of 20 minutes. The research on TDCS is still, however, limited, and the exact neurobiological pathways affected are yet to be found. This is why scientists are also using animal trials to find more information. Calmo et al. Stated that the effects of these sessions can result in long-lasting results when targeted at treating specific disorders such as depression. The image in the bottom right is an example of a TDCS machine, as well as the electrodes attached to the head. You can see that the electrodes are quite large, so careful placement must be taken to ensure they are in the desired location. As described earlier, the prefrontal cortex is known to be the brain region responsible for cognitive and emotional processing. When targeting major depressive disorder with TDCS, the anodes are placed on the dorsolateral area to help increase excitation of cognitive function, and the cathode is placed on the supraorbital region to inhibit excitation of this emotional regulation area. By bringing these two contralateral regions' function back into balance, it has shown promise to reduce relapse in sufferers of depression. It is believed that the reason for these lasting changes is due to the N-methyl D-aspartate, NMDA, connection to the resting potential of the membrane. When the direct current increases the firing rates, the NMDA regulates to a higher synaptic strength. This is likely due to the increase of calcium ions at the intracellular level. NMDA receptors are also known to affect GABAergic activity. As well as this, the anodal after effects are prolonged by the NMDA agonist, D-cycloserine, and also reduced by the NMDA antagonist, beta-adrenergic protanol. Depending on where the anodes and cathodes are placed on the brain, these different antagonists or agonists can be released to provide a lasting effect. In conclusion, the emerging research is pointing at TDCS being an effective, non-invasive, low-cost treatment to help major depressive disorder. With the physiological changes it promotes through the anodal stimulation in the dorsolateral prefrontal cortex and the cathodal stimulation to the supraorbital prefrontal cortex and the following NMDA changes down to the intracellular level. However, limited research has been done to this date. One concerning finding is that TDCS does not seem to work on resistant diagnoses of MDD. It is recommended that further research into the long-term effects and key markers that will highlight patient receptibility to the treatment are found. As TDCS hasn't proven more effective than first-line antidepressants, it was also recommended that further research looks at the compatibility of current treatments and TDCS.